So here we have our notes for rational expressions and operations. This is Math 023. It's Module 3. And we're going to start off. A rational expression is the quotient of two polynomials. So that means a rational expression could look something like, we could have x squared plus 5x minus 7 over, x minus 8. But anyways, it's two polynomials. Quotient, think fraction bar, division there. And then a rational expression is undefined when a value is substituted into the irrational expression and the denominator becomes a 0. Because if you remember, anytime you have a fraction, you can never have 0 on the bottom of your fraction. If this happens, it's undefined. And I always like to think of it this way. Okay, if we have 5 pieces of candy, we can't divide them into groups of 0. I always like to say we're not Harry Potter. We can't make things disappear. So bottom is 0 on the bottom is bad. I always think bottom bad for 0. So the first thing we're going to do is figure out when our expressions are undefined. When they ask you this, the only thing you're concerned about is the denominator. I don't care about the numerator. You can have 0 on the top of your fraction, but you can't have 0 in your denominator. So if we look at A, we're only concerned with this expression here, the 4x plus 7. And what we want to do is figure out what value or what number, if I plug it in for x, will give me a 0. So you take the expression, in this case it's linear, so we just set it equal to 0, and we solve it. So we're going to subtract 7 from both sides, and we're going to get 4x equals negative 7, and then I'm going to divide by 4, so I get x equals negative 7/4. So that is the value when the rational expression is undefined. X can be any number except negative 7/4. If we take a look at B, again, we're only concerned with the denominator, but this time it's a quadratic equation. It's to that second power. So when we solve it, remember, we do want to first set it equal to 0. But as we learned in the last section, to solve it, we have to either factor it or use our quadratic equation. Let's try to factor it first. And it's an easy trinomial. And we also have a plus and a minus in that order. So our two signs would be a plus and a minus. And then my factors of 5 are 1 and 5. So we have to use those. And I know that I want a positive 4, so I'm going to do a positive 5 and a negative 1. And then we'll set them both equal to 0, so we have x plus 5 equals 0 and x minus 1 equals 0. Subtract 5 from both sides, x equals negative 5, add 1 to both sides, so x equals 1. And again, we can write it as a solution set. But our expression is undefined when x is negative 5 or 1. So I can plug anything else in for x, and I'll be fine because I won't get a 0 in my denominator. But for these two values, this is where x is undefined. So now for example C, if you notice, in our denominator we have x squared minus 16. We have two terms, and it's a quadratic. And because we have subtraction there, check, are they both perfect squares? X squared is, because the square root of x squared is x. And then also 16 is, because the square root of 16 is 4. So remember, to factor the difference of perfect squares, we're going to do x plus 4 times x minus 4 equals 0. And then we're going to set them both equal to 0. So x plus 4 equals 0 and x minus 4 equals 0. So here I'll subtract 4 from both sides, and I get x equals -4. Here I will add 4 to both sides. So I get x equals +4. And my solution set, again, is -4, 4. And these are the two values that when I plug them into the denominator will give me a 0 in my denominator. So these are the only two numbers where the expression would be undefined. I can plug in any other number for x and get a fraction that would work, or a rational expression that would work. All right, if we take a look at D, my denominator, again, because that's the only thing I'm concerned with. I don't care about the top right now, because I'm only finding out where it's undefined. I have x squared plus 1. Now, when I look at this, it's a quadratic, so we need to factor it. But I have two perfect squares. The square root of x squared is x. The square root of 1 is 1. However, it's addition, not subtraction. And because it's addition, it is prime, so I cannot factor it. Okay, so it's prime. I can't factor it. So it's never going to be undefined. And you may say, well, why is that? Undefined. Let me write this correctly. But we have the x squared there. So if I take a negative number, like -3, and square it, it's going to give me a +9 plus 1, so it'll give me 10. Okay. Even if I did 0 squared, which is 0, if I add 1 to it, it gives me 1. Or you may say, well, what about -1? But if I square -1, it gives me a +1, and then I add 1. So for this one, you're never going to get a 0 in your denominator, so any value of x will work. So it is never undefined. That's what you would write. So now we're going to look at how to simplify a rational expression. And in order to simplify a rational expression, the first thing you want to do is factor. That's an A there. Factor. I'm going to rewrite that for you guys. That looks a little bad. All right. You want to factor the numerator and the denominator. Then, once it's factored, you can divide out factors that are common between the numerator and the denominator. So the very first thing you have to do is make sure you factored each numerator and denominator completely. So here for A, for the numerator, I can see we have a common factor of x. So I'm going to start and just factor out an x, which will leave me with x squared divided by x is x. And then 4x divided by x is 4. So we have +4. Then on the bottom, I have a common factor or GCF of 5. So I'll factor that out. And that's going to leave me with x plus 4. So now what we're going to do is we are going to divide out common factors. Remember, factors are what you multiply together. So if I look at this problem, I have two factors in my numerator. I have x and I have the expression x plus 4. It is, because it's times the x, the whole expression is the factor. And then on the bottom, I have 5 and the expression x plus 4. So when I go to simplify, I can only divide out or turn into ones those like factors. So in this case, my x plus 4 is the same on the top and the bottom. So that would equal 1. So when I divide those out, it gives me a 1. So it's really like I have this. I have x times 1 on the top, 5 times 1 on the bottom. I don't need those ones, so my final answer is x over 5. Now, be careful, because a lot of you will say, well, if you had something other than, let's say we had, x plus 5 on the top as the expression and x plus 4 on the bottom. A lot of you were like, well, I can cancel out the x's because they're the same. You can't because they're part of a family. They are part of that expression. They are not a single factor by themselves because it's x plus 5 times something and x plus 4 times something. And I always say to this, it's like you're busting up a family. So you're taking the mom away from the kids. So think of it that way. You can't simplify unless it's a common factor. So you can't take parts out of an expression. So an expression with like addition or subtraction. So you have to simplify common factors. So if we look at B, the nice thing about B is the top is already factored. So we have x plus 4 on the top. And then on the bottom, we have x squared minus 16, which we just factored earlier. So we know it's going to be x plus 4 times x minus 4. And again, I'm looking for common factors. If it helps, it doesn't have parentheses, but you can put parentheses around that expression on the top. And again, what we can get rid of are my x plus 4s. Now, it cancels, but it really equals a 1. So what we need to do is I can't just write my answer as x minus 4 and call it done. My x minus 4 is on my denominator. I need to have a numerator. Again, because this turned into a 1, we're going to put that 1 on the top. So it's really 1 over x minus 4. So if we take a look at C, again, we can factor both the numerator and the denominator. So for C, in the numerator, I have a common factor of x. So when I factor it out, it's going to be x times x plus 1 over, now x squared minus 1, two factors. It's a quadratic, and they're both perfect squares. So it will factor as x plus 1 times x minus 1. And again, when I'm looking for those common factors, it's x times x plus 1 on the top, x plus 1 times x minus 1 on the bottom. My common factor that I can divide out or turn into a 1 will be the x plus 1s. And then my simplified expression is what's left over, so it will be x over x minus 1. And we can't do any more. We cannot get rid of the x's because the x on the top is a single factor, but on the bottom, the factor is x minus 1. And if we divided out our x's, we would be, again, busting up families, and we can't do that. All right, let's take a look at D. So we've got to factor both the top and the bottom. It's a quadratic. So on the top, we have an easy polynomial or trinomial. I'm going to put my x's there. A minus and a minus means we're going to have 1 plus and 1 minus when we factor. And the factors of 10 are 2 and 5 and 1 and 10. And I need something that will give me a 3, a negative 3. So the 1 and 10 won't work. I'm going to have to use the 2 and 5. I need a negative 5 or a negative 3, so I'm going to make it a negative 5 and a positive 2. Okay, and then I'm going to factor the bottom. Again, 2 terms, both perfect squares, so we'll do the difference of perfect squares. So we have x plus 5 times x minus 5. And when I go to simplify, again, my common factor here, it's going to be x minus 5. Can't do anything with the x plus 2 or the x plus 5 because they're both factors and they're parts of expressions, so I can't get rid of the x's. So it's going to leave me with x plus 2 on the top and x plus 5 on the bottom, and I'm done because I can't do anything else. So the next operation we're going to do is we're going to look at multiplying and dividing rational expressions. And just a reminder, when we divide fractions, we actually change it to multiplication and divide by the multiply by the reciprocal. That is the same with rational expressions. If you're dividing two rational expressions, you want to change to multiplication by taking the reciprocal of the second expression. P, reciprocal. And then to multiply, you have to factor all your polynomials. In both expressions if possible. And then to finish, you cancel the like factors or divide out, just like we did when we were simplifying expressions between your numerator and your denominator. Just a reminder for reciprocals, if I have something like 2/5, the reciprocal is going to be 5/2. You flip the fraction. So here we're going to start with our first example. In example A, it is one rational expression with a monomial. And to help you out, if it makes it easier, do this. Just put a 1 underneath that x cubed. So now you have two fractions. When we multiply, we typically go straight across. These are all factored as much as we can. So I'm going to multiply straight across, and it's going to give me y squared x cubed over 13x to the 7th. So I multiplied straight across because I think it's a little bit easier. And now I'm going to use my exponent rules. If you think back to 022, Math 022, what we're going to do is we're going to subtract. I can't do anything with the y or the 13, but my x cubed and my x to the 7th power, I can subtract those exponents. So if I do that, if I do 3 minus 7, it's going to give me a -4. So right now, whenever you subtract, it always brings it up to the top. But you can't have a negative exponent, so we're going to move that down to the bottom. So my final answer will be y over 13x to the 4th. Now for B, because we have some pretty big numbers here, I'm going to start off by, I can cross simplify. If I have a numerator and denominator with a common factor, I can pull that out. So I know that 3 and 36 have a common factor of 3. So what I'm going to do is divide both those numbers, 3 and 36, by 3. And when I do that, it's going to give me x squared, or 1x squared, because 3 divided by 3 is 1, times, and then on the bottom, I'm going to have 36 divided by 3 is 12, and it'll be x to the 4th power. I'm not going to worry about the x's just yet. Sometimes I think it's easier to multiply those straight across and simplify. It's up to you. Now 25 and 35, I do also know that they have a common factor of 5, so I'm going to divide them both by 5 to get some smaller numbers. So 25 divided by 5 is 5, and then we'll keep our, what is it, y to the 4th power there. And then on the top, 35 divided by 5 is 7, and we have y to the 6th. Okay. And our numbers are as small as they can be, so I'm going to go ahead and multiply straight across, and it's going to give me 7, put the numbers first, x squared y to the 6th. And then on the bottom, 5 times 12 is 60. We'll have x to the 4th and y to the 4th. And I just put my variables in the same order as the top to make it a little easier. And what I want to do is now I have to worry about my x's and my y's. I have to simplify those. And again, I'm going to use my rules of exponents and subtract. So the 7 over 60 I can't do anything with. Can't simplify it, so we're going to leave it like that. Now, x's, if I do 2 minus 4, it's going to give me a -2. And whenever you subtract, it puts it on the top. And then y's, I'm going to do 6 minus 4, which will give me 2. So I'll have y to the 2nd. But then if you recall, with those exponents, you can't have a negative exponent. So we're going to move this to the bottom. We'll take the reciprocal to make it positive. So now I have 7 y squared over 60 x squared. And that's my final answer. I can't do any more. Now, if we take a look at C, the other two were multiplication, but C is division. So the very first thing you want to do is rewrite that as a multiplication problem. So remember, with division problems, you keep the first fraction as it is. So we're going to keep the 6 a squared over 7. But the division becomes multiplication, and you take the reciprocal of the second fraction. Before you do any simplifying, you want to take that reciprocal. So we're going to have 14a cubed over 9a to the 6th. And now again, I'm going to do some simplifying of numbers before I do any variables. So I know that 6 and 9, again, it has to be a numerator, denominator, have a common factor of 3. So I'm going to divide both of those by 3. So that's going to leave me with 2a squared. And then on the bottom there, it's going to be 3a to the 6th. And then I also know that 7 and 14 have a common factor of 7. So we'll divide both of those by 7. Sorry, my stylus is not working today. All right, 14 divided by 7 is 2. So we'll have 2a cubed on the top. And then 7 divided by 7 is 1. So we're going to put a 1 there. And then we're going to multiply straight across. So 2 times 2 is 4. A to the 2nd times a to the 3rd. Remember, you add your exponents, so you get a to the 5th. And then on the bottom, 1 times 3a to the 6th will give me 3a to the 6th. Again, we need to simplify those exponents. For the a's, the 4/3 I can't really do anything with. We're going to leave it improper. We don't have to turn it into a mixed number. We just want the fraction in lowest forms. So if I subtract 5 minus 6, I get a to the negative first. But again, we want to make the a's positive, so I will do the reciprocal. I'll move the a to the bottom. So our final answer is 4 over 3a. And the key thing here is just remember, make sure you take that reciprocal. All right, now for D, it's multiplication, so I don't have to flip anything. But I do need to factor my expressions. I can factor them out. And the 6x plus 6, I can pull out a greatest common factor of 6. So that's going to leave me with x plus 1 over 5 right now. And then we have times 10 over 18x. Again, pull out an 18. So it's going to leave me with x plus 1. And right away, I can see a common factor of x plus 1. So I'm going to get rid of those. And this is what I have right now. I have 6 over 5 times 10 over 18. And we have those numbers, and we can do simplifying with those. Like I know that 6 and 18 have a common factor of 6. So I'm going to divide both of those by 6. And my 5 and 10 have a common factor of 5. So I'm going to divide those by 5. And that's going to leave me with 6 divided by 6 is 1. 5 divided by 5 is 1. 10 divided by 5 is 2. And 18 divided by 6 is 3. So my final answer is going to end up being 2/3 when I simplify everything. So now for E, again, if you look, it is division. So we have to first change it to multiplication before we do any factoring or anything. So the first fraction stays the same. So we'll have x squared plus x divided by x squared minus 1. And then division turns to multiplication. And you take the reciprocal of the second fraction. So we'll have x minus 1 over 11. And now what we're going to do is go ahead and factor everything that we can. My reciprocal is already all factored, so it's really the first fraction that we have to factor. The x squared plus x, I can pull out a common factor of x, so it'll be x times x plus 1, because if I divide x squared by x, you get x, and x divided by x equals 1. And then on the bottom, if you recall, that's your difference of perfect squares. It is 2 perfect squares with subtraction, so it will factor into x plus 1 times x minus 1. And then I'll put my times x minus 1 over 11 here. And now we're just looking for common factors that we can pull out. It has to be a common factor of the numerator and denominator. And we have x plus 1 here and x plus 1, so I can get rid of that. And then we also have x minus 1, which is a factor, and x minus 1. And then we're only left with the single x and 11, and we can't do anything with it, so my answer is x over 11. All right, let's take a look at f. It is multiplication, so we're good there. We just need to factor everything. So the x squared minus 4x plus 4. We have to factor that. And because it's a minus and a plus in that order, our two signs when we factor it are going to be two minus signs. And we need a negative 4. My factors of 4, I could do 1 and 4 or 2 and 2. But if I'm using two negatives, if I do 1 and 4, I'd get negative 5. So I'm going to do 2 and 2. And then on the bottom, we can pull out a greatest common factor of 2. So it'll be 2 times x minus 2 times, and then on the top we have x plus 3. And on the bottom, x squared minus 4. Again, it is difference of perfect squares. So when I factor it, it's going to be x plus 2 times x minus 2. And now we're looking for our common factors. So I can take out a pair of x minus 2's here. And then I also have another pair of x minus 2's here. I don't have any x plus 3's or other x plus 2's or that 2. So what I'm left with is going to be my answer, my 3 factors that are left. So it will be x plus 3 over 2 times x plus 2. And that's our final answer. We can't do any more. So here we are adding and subtracting like rational expressions. Like rational expressions are going to be rational expressions that have the same denominators. So to add or subtract like rational expressions, basically what you're going to do is combine your numerators and then simplify if possible. It's like adding fractions. You have to have a common denominator. We have a common denominator. And for instance, the first one, our common denominator is x minus 1. So it's addition. So we're going to add our numerators together. We'll combine like terms. So x plus 3x will give me 4x. 3 plus 10 will give me 13. And it's going to be all over x minus 1. Now you want to look at it and see, can we simplify it? I can't factor the top and I can't factor the bottom, so we're done. Now b is a little bit different. It's subtraction, so we just have to be careful. Our denominator is the same for both, so we have 3x plus 7. But what we're doing here is we have 5x plus 4, and we are subtracting this whole expression of 7x minus 21. So remember, that minus sign means it's like that negative 1 that's there. So you have to distribute that minus sign to each term on the inside of that second expression. So we're really doing 5x plus 4 minus 7x, because a positive times a negative will give us a negative. So positive 7x, negative 1. And then plus 21, because two negatives make that a positive. And that is still over 3x plus 7. So now we'll combine our like terms that we've taken care of the negative. 5x minus 7x will give me negative 2x. And then 4 plus 21 will give me plus 25. And it's all over 3x plus 7. And again, now you want to see, can you factor? We can't simplify before we add or subtract, but we can't factor either, so we're good. Okay, for C, our common denominator is x squared minus 4. And for now, I'm just going to leave it x squared minus 4. We will have to probably factor it in the end to simplify. And then it's addition, so I'm going to combine my like terms. And I have 4x minus 3x, so that's going to leave me with an x, negative 9, plus a positive 7 will leave me with minus or negative 2. Okay, and then I just want to see, can I simplify anything? And I can factor the bottom. So I can make it, again, x plus 2, x minus 2, because it's the difference of perfect squares. And I have x minus 2 on the top. So again, remember, I can simplify by dividing out common factors on the numerator and denominator. Now I can't leave my numerator empty, so I'm going to put my 1 there, and my answer is 1 over x plus 2. Now for D, my denominator is x plus 7, and they're the common denominator, so we'll leave that. On the top, remember, I have that subtraction, so I have to apply it to both terms on the top. So it's like distributing a negative 1. So I have x squared plus 9x minus 4x minus 14. So a negative times a positive is a negative. Combine my like terms. So I'm going to have x squared plus 5x, because 9x minus 4x will give me 5x, minus 14 over x plus 7. Again, we want to see, can we factor anything to simplify? The top, I can factor it. If we have a plus and a minus in that order, we'll have 1 plus and 1 minus. And 14 is 2 and 7, or 1 and 14. And I can do 2 and 7 to get that positive 5. So I need a positive 7 and a negative 2 over my x plus 7. So my common factor here that I can simplify out is the x plus 7. So my final answer is x minus 2. You can put it over 1, but we don't need it. So we're just going to say our answer is x minus, not plus, minus 2. So the last part of our notes, what we're going to start looking at is how to add rational expressions or subtract them if you don't have a common denominator. And just like with regular fractions, when we add or subtract regular fractions, we have to have a common denominator. So if our denominator isn't common to start with, we create one using common factors. We're going to learn how to do that here with rational expressions. And the least common denominator of a set of rational expressions is the highest power of each unique factor in any factored denominator. So if we take a look at A, we want to look at our each unique factors, which means our different factors. For A, I have x squared and x, so the factor is the same. We have x squared and we have x. But I want to find the highest power. So between x squared and x, the highest power would be x squared. So that is my LCD for those two expressions. That one was kind of easy. Now B, we have 2a cubed and 5b to the 4th. So I'm going to rewrite it. I'm just going to put, we have the 2, we have the 5. So between our numbers, we have to find a common factor. And with numbers, you really are looking at like your multiples. So for 2 and 5, like if I had 1/2 and 1/5, if I were going to add them together, my common denominator that I would use would be 10, because that's their lowest common multiple. So my LCD, we're going to need to use 10 for my numbers for 2 and 5. So I've taken care of those. Now my other two factors, I have a cubed and b to the 4th. I need to include all of my unique or different factors. Because I don't have any other a's, I'm going to use a cubed. So I'll use the highest power, which is a cubed. And my b's will be b to the 4th. So I'm really just going to tack them on. So that's my LCD for that expression. Now for C, again, if we look at our numbers, focus on those first. We have 3 and 9. So my greatest common or my least common multiple, my factor common multiple for 3 and 9 is going to be 9. And when you're looking at your numbers and you're finding a common denominator, your common denominator cannot be lower than your highest number. Now, both expressions have a p. So I need to include that. Now I have p squared and p. You want the higher of the two, so we're going to do p squared. And they both have a q, so that's our other unique factor. But we have q and q squared, so we're going to go with the q squared. So my GC, or not my GCF, but my least common denominator here is 9p squared q squared. Okay, if we look at D, D is easy, but it's hard. We only have two individual factors because remember, expressions, they're like their own little factors. So we put the parentheses around those. And our LCD is always made up of each unique factor. Well, we have two different factors here. They're both raised to the first power. So my LCD for this one, we are simply going to put the two factors together. So it's going to be x plus 3 times 2x minus 1, because those are my different unique factors. And I can't do any factoring to it. There are no like x plus 3 to the second powers. So that is my LCD. You just put the two together. Now for E, you want to make sure your denominators are fully factored before you find the common denominator. So 4x plus 2, I know that I can factor out a 2. So it becomes 2 times 2x plus 1. That's that. And then let me do a different color. The 6x plus 3, I can pull out a 3. And it gives me 2x plus 1. So now, common factors, each denominator has a 2x plus 1. So I know that my LCD is definitely going to have the 2x plus 1. And then my other two factors are 2 and 3. And again, you want to find that common denominator. If I have 2 and 3, my common denominator, if you think of your multiples of 2, it's 2, 4, 6. For 3, it would be 3, 6. So my least common multiple for 2 and 3 would be 6. So that's going to make it my LCD. We have 6 times 2x plus 1. And then for our last one for F, again, make sure you factor each denominator. So x squared minus 9, difference of perfect squares. It's going to be x plus 3 times x minus 3. And then let me do a different color. The 4x minus 12, my common factor there is a 4. When I factor it, I'm going to get x minus 3. Okay, so if I look at my unique factors, I have, in this problem, I have two different factors, and here I have two different factors. X plus 3 is one of my unique factors. It's not in both, but I have to include it in my common denominator. Any unique factor is in your common denominator. So we'll put x plus 3 there. Now, both of them have x minus 3, and they're both to the first power. So I'm just going to include an x minus 3. And then my only other factor that I haven't used is 4, because there are no other numbers. 4 will be the common factor, so I'm going to put it at the front because we're used to seeing it there. So my LCD is 4 times x plus 3 times x minus 3. Okay, so now we're going to do our last part, which is adding and subtracting unlike rational expressions. So first, you have to begin by factoring all your denominators if necessary. And we do this so that we can find the LCD. Okay, then we're going to name the LCD and rewrite each rational expression using our LCD, or our least common denominator. And then we will combine our numerators and simplify the answer if necessary. So if we take a look here at A, we have 1 over 6x plus 2 over 3x squared. So the first thing we need to do is find our LCD. Again, look at those unique factors. We have a 3 and a 6. So for my numbers, my LCD is going to be that 6, because remember, factors or multiples of 6 would be 6, 12, 18. Multiples of 3 would be 3, 6, 9. The lowest common multiple they have is 6. And then again, we have x and x squared. It's the same factor, but you want to choose the highest power. So we're going to choose x squared. So that's my LCD for this problem. And that means I'm going to take my 1 over 6x and my 2 over 3x squared, and I want to change them both so that they have a common denominator of 6x squared. And here's where you have to fix your numerator as well. So to go from 6x to 6x squared, I had to multiply the 6x times x. So whatever you do to the bottom, you do to the top on the fraction. You have to be fair. So 1 times x will give me an x. And then here, 3x squared, in order to make it 6x squared, I had to multiply by 2. So if I did that on the bottom there, I have to do the same on the top. So that gives me a 4. And now what I'm going to do is just add my numerators. So x plus 4, I can't combine them and make it 4x because that's multiplying, but I can add it and write x plus 4 over 6x squared. And then I can't do any simplifying, so we're done with that one. Now for B, if we want to find our LCD, let's see here. Our numbers again are 2 and 6, so my LCD will be a 6. We have a cubed and a, so that's the same factor, but the highest power is a cubed, so we'll have 6a cubed. And then when I go, that's my LCD is 6a cubed, so if I take them and my 7 over 2a cubed, if I make it into 6a cubed, the difference between the two is they had to take the 2 to the 6 and they multiplied by 3. So we'll multiply the top by 3 and get 21. And then I have my 5 over 6a squared that I want to turn into 6a cubed. So again, to go from 6a squared to 6a cubed, I'm going to multiply by a. So do the same thing on the top, so I get 5a. Okay, and then it's a subtraction problem, so I'll subtract 21 minus 5a. They're not like terms, so all I can do is write it as an expression over the same denominator. So it'll be over 6a cubed. And we can't do any simplifying, we can't factor anything, so we are done. All right, now for C. We again have this expression on the bottom of one and this expression on the bottom of the other. So my LCD is simply going to be to put those two factors together. So my LCD is going to be 3x plus 1 times x minus 5. So that means my 3 over 3x plus 1, we need to go to a common denominator of 3x plus 1 times x minus 5. So what was missing from this factor here, what I have to multiply by is x minus 5. But again, if I do something to the bottom, I have to do the same thing to the top. And then when I multiply the top, that's going to give me 3x minus 15. Okay, and then my second fraction we're adding here, but we have 4 over x minus 5, and I need to turn it into a common denominator of 3x plus 1 over x minus 5. And again, I'm missing from this one the 3x plus 1. So I'll multiply the bottom times that, but I do the same thing on the top. So it's going to give me 12x plus 4. And it's addition, so I'm going to add my like terms to get my answer. 3x plus 12x will give me 15x. Negative 15 plus positive 4 will be minus 11. And then it's all over 3x plus 1 over x minus 5. And I can't factor the top, so it's simplified. We can't do any more. All right, D, again, is going to be very similar. It's the same thing. We have these two unique expressions, and I can't factor them at all, so I just put them together for my LCD. So my LCD will be 4x minus 3 times 2x plus 5. So now we do have subtraction here, so we have to be a little careful with that. But if I take my 1 over 4x minus 3, I turn it into a common denominator of 4x minus 3 times 2x plus 5, I am missing the 2x plus 5. So I'm going to multiply both sides by 2x plus 5, or the top and the bottom by 2x plus 5. So that's going to give me on the top here, 1 times 2x plus 5 is 2x plus 5. Now, we have our 5, and what I'm going to do to make it easier to distribute that negative, I'm going to go up to this original problem and make it plus a negative. So change it to addition of the opposite. So now I have negative 5 over 2x plus 5. And again, I need to turn it into my denominator of 4x minus 3 times 2x plus 5. So what is missing here is the 4x minus 3. So I'll multiply. If I did the bottom times that, I'll do the same thing on the top. So on the top, because I have that negative 5, it helps me distribute that negative. I'm going to get negative 20x. And that's negative 5 times negative 3, so plus 15. And now what I need to do, because I distributed the negative already, I'm just going to combine like terms between my 2x plus 5 and my negative 20x plus 15. So negative 20x plus 2x will give me negative 18x. 5 plus 15 will give me 20. And it's all over 4x minus 3 times 2x plus 5. And I can factor the top. I can pull out a 2 or even a negative 2, but it's going to give me 9x plus 10, and that can't be factored on the bottom, so we're going to leave it as is. All right, so we have two final examples. And for here, for E, The x minus 2 is already factored, but 2x minus 4, I can factor that. I can pull out a 2, so it's going to become 2 times x minus 2, which is nice because we already have the x minus 2 as a factor, and then we have the 2. So really, this right here turns into our LCD because that's both of our unique factors. So my LCD that I'm going to use is going to be 2 times x minus 2. So first I'm going to start with my negative 5 over x minus 2. And to get it to my common denominator of 2 times x minus 2, I'm only missing the 2. So I'm going to multiply the top and the bottom by 2. And I already got my common denominator there. So negative 5 times 2 will give me negative 10. And then my second fraction, my 1 over 2 times x minus 2, it's already done, so I don't have to do anything. So it's just going to be same thing, 1 over 2 times x minus 2. And then we'll combine numerators. It's addition, so negative 10 plus 1 will give me a negative 9 over our common denominator of 2 times x minus 2. And again, I can't do any simplifying, so I'm good. And f, all right, let's see. X squared minus 1, difference of perfect squares. So I can factor this denominator and make it x plus 1 times x minus 1. So now we have two different factors, or unique. So you're looking for all your different factors. And it happens when I factor this, that this, again, is going to be my common denominator because they both have x minus 1, but they're both to the first power. So you just use, one of them. So this is my LCD. And so the 3 can stay the same. So it's 3 over x plus 1 times x minus 1. And then it's going to be minus 6. But to get the 6, I'm going to write it up here. Just to get this to my LCD of x plus 1, x minus 1. We have the x minus 1 already. We need the x plus 1. So we're going to multiply the top and the bottom by x plus 1. So that's going to give me on the top, when I do this, it's going to be minus, and again, I'm going to make it plus a negative 6, and we'll do that here. So negative 6 times x will give me negative 6x. And negative 6 times positive 1 will give me a minus 6. And it's all over the x plus 1 times x minus 1. So combine our like terms. We'll keep our negative 6x. 3 minus 6 is minus 3. All over x plus 1 times x minus 1. I can factor the top. I can pull out a 3. But if I do that, even if it's a negative 3, so we'll do negative 3, it's going to leave me with 2x plus 1, which is good, but I can't factor anything out. I can't simplify it at all. So you could have left it in the factored form because you can't do any simplifying. But that's it.